Hello viewers, welcome to our channel Textbook Reading. So today we are reading Physics Class 9 Chapter 1 Matter Around Us Part 4. So make sure you watch Part 3 before viewing this video. So let's get our physics textbook. Here is our physics textbook. Let's open it to page number 7. Again take out 10 ml of this solution and add to another 90 ml of clear water. Carry out this process 4 or 5 times as shown in figure 8 and observe changes in intensity of color of the solution. Is the water in the last beaker still colored? How is it possible for 2 small crystals of potassium permanganate to color a large volume of water? What do you understand from this activity? Repeat the activity by taking a few crystals of copper sulfate instead of potassium permanganate. Several interesting conclusions can be drawn from the above activity. We can conclude that there must be several tiny particles in just one crystal of potassium permanganate which are uniformly distributed in water to change its color. Similarly, a few crystals of copper sulfate too has several tiny parts which are distributed in large quantity of water to give color. So both solids and liquids including water are made up of tiny particles. How do you particles of the solid distribute in the liquid? Let us find. Activity 8. There exists space between particles. Take a graduated beaker and fill it with some water and mark the water level. Add some salt and stir it thoroughly with glass rod. Observe if there is any change in the water level. Add some more salt and stir it again. Observe the change in the level of water. Does the level of water change? Where did the salt go? Can you see it in the water? From the activities 7 and 8, we can conclude that liquid particles in a liquid have some space between them and the solid particles enter into the space between the liquid particles on dissolving solid in liquid. Recall the incense stick activity. Do you agree that gas is also made up of particles and they have large space between them? Particles of matter attract each other. Activity 9. Observing the force of attraction between the particles of matter. Open a water tap and allow the water to reach the ground. Now try to break the stream of water with your finger. Can you break the stream of water or momentarily or permanently? Are you able to break the stream of water anywhere from the tap to ground? What is the reason behind the stream of water remaining together? Now try to break a piece of iron nail with hammer. Are you able to do it? If yes, does it rejoin? What about a piece of chalk? From the above observations, we can say that particles of matter have forces acting between them that keeps the particles together. It is also clear that this force is not equally strong and different in different forms of matter. How diffusion takes place? We have already carried out several activities to explain diffusion of particles of solids, liquids and gases. Diffusion can be possible only when particles of matter move continuously. In the incense stick activity, the particles responsible for scent move and enter the space between the air particles. The scent particles quickly spread across the room. The particles of solid, liquids, gases can diffuse into liquids and gases. Rate of diffusion of gases is higher than liquids while rate of diffusion of liquids is higher than solids. There are two reasons for higher rate of diffusion of gases. Speed of gas particular particles is very high. The space between gases particles is very high. Similarly, the greater diffusion in liquids compared to solids is because particles in liquids move freely and have greater space between them when compared to particles of solids. Observe the following diagram, which shows the difference in arrangement of particles in solids, liquids, and gases. In a gas, the particles are not as close together as in the liquid. If a colored gas is mixed with colorless gas, the color spreads evenly in it. This happens faster in gas than liquid because a large gaps between particles of gas. Fewer particles of gas obstruct in the way of spreading. Can you see the diffusion of bromine when it diffuses air? Bromine is brownish colored gas. Hence, its diffusion is colorless in air can be seen clearly. If we allow bromine to diffuse in vacuum, it diffuses in vacuum because there are no particles to obstruct its way. By this page, we end the chapter of the matter around us chapter. So this is the end of the video, and please like, share and subscribe to our channel Textbook Reading. Any improvisations and comments, please comment below. Thank you for watching.